It's with great pleasure that I'm able to introduce Sanford Kwinter as our lecturer this evening and welcome him to CCA. There are a few moments when you get to thank your own mentors publicly. And Sanford, who was one of my doctoral advisors at the GSD at Harvard many years ago, had a profound effect on my own thinking, something for which I am truly appreciative. Sanford is a professor of architectural theory and criticism at the Harvard University Graduate School of Design and co-director of the Master of Design Studies program. He's a theorist and a writer and was the co-founder and editor of the journal Zone and Zone books for 20 years, one of the most innovative and brilliant series of books to be published in the last 2 decades. The kind that become collector's items the minute that they are out of print, because they really are truly singular contributions to culture. Zone 1-2, The Contemporary City, which was published in 1986, which took me years to actually find a copy of, a book that marked Sanford's first public intersections with architecture, focused on defining a political regime for the city understood as a medium for the circulation of populations, information, and commodities, a constellation of material flows and perceptual effects. It was not only a critical collection of writings, but also championed great design in its very making, since the Zone journal and book series that was designed by Bruce Mau also launched another parallel trajectory in a related but distinct field. Sanford received his PhD from Columbia University, and given his background in literature, philosophy, and the history of science, his writings mine the intersections of these disciplines with design, architecture, and urbanism. He's an inspirational thinker and teacher, embodying a creative material intelligence that is grounded and precise, yet exceeds historically repetitive and mimetic approaches to thought. His work is transdisciplinary in practice, inventive in the way that thought should be, and certainly radical in approach, in that his thinking and concepts are rooted and deep, ramified and complex, and certainly revolutionary. Coming, as he does, from outside the discipline of architecture, he exceeds the approach and parameters of architectural thinking, but is able to re-raise core issues, such as those surrounding form and technology, within an entirely new intellectual context. He has made a critical contribution to the intellectual practice of architecture and is undoubtedly one of the most important thinkers of our time. In addition to being an editorial member of the Any Conferences and Publications and the architectural journal Assemblage, he's also the author of numerous articles and books, including Architectures of Time, Towards a Theory of the Event in Modernist Culture, published by MIT Press, Far from Equilibrium, Essays on Technology and Design Culture, published by Actar, and Requiem for the City at the Turn of the Millennium. Along with his current position at Harvard University, Sanford has also held faculty positions and chairships at Rice, Cornell, MIT, UIC, Penn, and SUNY Buffalo. Please join me in welcoming Sanford Kwinter.
That was a big hug, 25 years in the, I don't know if it was that long ago that Isla and I met. I'd like to return the favor of that rather humbling and I don't know how true introduction because I actually met Isla on what was the equivalent, I'm not going to go on long, I have a very long lecture for you guys tonight, which will try your patience probably in many ways. But I do want to say that Isla evoked that moment when my very first class at Harvard. Do you know that, Isla? And I remember at that point, you know, people were very curious, and the classrooms at Harvard were extremely small, and there were no windows or anything. But I remember there were people sitting, you know, right around wherever it was that I was standing, and Isla was sitting on the floor because she was late or something. And I hadn't assigned any readings yet, but I decided, why not? And what am I waiting for? And I started in on a lecture of Deleuze and Guattari's something in 1,000 Plateaus. Isla's eyes just got bigger and bigger as the lecture went on. I got to tell you, until there was like almost like a green glow coming out of them. And I'd have to say, you know, at that point there was no stopping her. You guys didn't have the pleasure of reading Isla's doctoral dissertation, but it's probably the most sustained and probably the deepest study of Deleuze that our field, and this was probably, if I remember correctly, the very well, somewhere in the 90s, but in the 90s that was somewhat obsessed by Deleuze. It was something else. So Isla's very, generous in remembering it as somehow I inspired her, but it was clearly the work of Deleuze and Guattari that day or that semester. I am going to cut right to the chase. I want to thank Isla, actually, for the ways in which she introduced me. I asked her to not please introduce me at all, or just to keep it to 20 or 30 seconds. But now I'm grateful for some of the things that she said. I mean, I'm grateful for all of it. But the things that I find particularly useful today is the reminders that I don't really go out of my way to talk about architecture that much. That was sort of the other side of it. And I do because I love it. But in the end, I feel like you have to back up. Actually, increasingly today, you have to back up several steps in order to get a better leap. And a lot I see of what I do is essentially doing that. So these comments about transdisciplinarity, et cetera, if they do anything, they should at least justify me in what I'm presenting to you today. There's a lot of polemics that I could present. I want to tell you right now in advance. I have to cut to the chase sometimes to get through this lecture of mine. I gotta get this bloody phone out of my pocket. I hope it's off. How about that? It wasn't off, so we could have had... I'm going to talk about nature, in a way. I'm going to talk about animals. I'm going to talk about a lot of things that have to do with... but it's particularly, I suppose... Well, we all know that in some ways it's a duty to think about nature today. The sustainability movement, I use that word for all the good and bad reasons, represents for us a kind of obligation to think and act, maybe, and live and organize differently. It strikes me that most of what passes for thought in that, whoa, why did it get so dark all of a sudden? So this is actually how it's going to be. Lights in my eyes, I can't see a thing. Okay, when I get the slides up, will I be able to see you? Okay, well, anyway. Okay, I just missed that. What was the funny joke? What happened? All right. Where was I? I was about to, let's say something controversial and turn around and run. Sustainability is one of the most disappointing of developments of, I would say, intellectual developments, especially in our field, something that really seriously needs to be thought through with fresh ideas, with some experimental ideas. There has to be a kind of radicalization of the objects that it's supposed to think, precisely, I like that better, the relationship between us and the so-called natural world. And I know those are terms that are important to understand in philosophical and critical ways, but there's also an immediacy that's required. And I would say, just to cut to the chase, that some of what I want to present today is the findings of what I consider to be some of the most incredibly interesting and radical thought about nature. Let's see if this works. Well, okay. I'm going to read because otherwise we'll really never get through this. For those of you who managed to stay to the end, is a kind of a nice little treat. It's kind of heavy stuff. The truth is when I was immersed in this stuff, it was almost 8, 9, I don't know, quite a long time, not that long ago. I mean, of course, it was many months ago when I was really immersed in this stuff. This paper really was coherent to me. When I started looking at it on the airplane today, I said, the good news is I got a really clean PowerPoint for you to watch, and it'll help. It'll help. Most textbooks and surveys fix the origins of the science of ecology in the work of Alexander von Humboldt, particularly his 1802 essay on the geography of plants. There's little need to contest this genealogy, mainly because we do not know what it means in the first place to speak about the origin of a term, ecology, that has never been concretely defined. What I'd like to present today consists of a proposal not to radicalize ecology. I'm not an ecologist as such, and it wouldn't really be my job, but to ask in what ways ecology may have already and may uniquely be able to continue to radicalize us. The approach to this task will also be an approach toward a needed definition. I like to define it. It's kind of easy to go along and add little points to the definition. I do think it's really important. It's a great word. It's got a great history. We don't have a clue really what it means. It's actually, in a certain sense, it's a very powerful cosmological term almost. As a theorist, my interest in what might be called, my interest is in what might be called ecological thinking. The unity and power of ecology as a discipline, I would argue, is not to be reduced to its role at the foundations of biological thought, although it is also this. It really is the beginning of modern biological thinking. But for the philosophical postures and the habits of mind, and I would almost say the habits of design, which are yet to come, but are on their way, that it has brought into play not only in the life sciences, but in all aspects of both our knowledge systems and our experiential worlds. Von Humboldt showed how plant shapes, sizes, and behaviors were dependent on variables in the immediate environment, such as the altitude at which a plant appears, the climate, the soil, the latitude, etc. All those variables would actually change the shapes. One and the same genotype, or genetic, one basic type of seed, let's say, was seen to express itself along a wide spectrum of variations according to which conditions it encounters in temporal and spatial location. So temporal and spatial location has an enormous role to play, if you like, in determining final outcomes, formal and behavioral outcomes, and other outcomes as well. Those categories to be mentioned later. Von Humboldt was among the first to embed the study of forms within a field of influences, and hence began a great series of fundamental changes in how we understand the concept of environment. His phrase, alles ist Wechselwirkung, typically translated as everything is connected, it's actually wrong. It's a mistranslation, and the mistake is very interesting or very instructive. It's more critically and accurately translated as all is interaction. To von Humboldt, everybody's going to see, whoa, parametricism, yes, we always knew it, and this roots now are in the even the late 18th century, and finally, the Enlightenment and parametric, no, not as such. Why? Largely because it has not been accompanied by ecological thinking. To von Humboldt, we owe the habits of thinking about form and nature as an expression of interactions that more or less incorporate or synthesize the environment itself. That's a very important idea, one of the central and first ideas of ecology. In von Humboldt, I would situate the notion, later dear to romantic theorists and artists alike, poets, etc., that form is the expression of embedded forces, hence, indeed, the beginning of ecological thinking. But von Humboldt's friend and elder, Johann Goethe, had completed a work on botany himself barely 10 years earlier. This is a new edition. Actually, the first, it's just Came out last year. I mean, the translation was still available. You had to go looking for it, but first time it ever came out in English as a separate book. It's a beautiful book, too. They have beautiful photographs, etc. It's a really important book, too, as I will try a bit to explain. Completed a work on botany himself barely 10 years earlier, 1790, that some today view as the origin of dynamical systems thinking. In his work on the metamorphosis of plants, Goethe supplies a single model of algorithmic explanation, 1790, at once for the diversity of vegetal forms in the world, as well as for the diversity of individual organ forms within the same plant, or within the same plant family. Stem, leaves, calyx, and petal, and all forms in between are related as organizational points in a space made up of three interacting fields of influence. What are they? A flexible type, a continuous gradient, and a closed but repeating cycle. And basically those three elements interact with one another and produce the incredible diversity of plants, but especially it's also the logical and syntactical structure of single plants. I mean, it's an astounding insight. As Ernst Cassirer brilliantly summarized it, Goethe effectuated the transition from generic thinking, from the habits of thinking about form within the fixed and decidedly topological, big mistake, Sanford, typological. We understand that word, right? Typology. It's like a no, it's a bad thing, right? Nowadays it's a bad thing, and I will continue the pile on the typology problem. But don't let's get caught up in the fun about trashing typology. Let's not get distracted. Anyway, the decidedly typological Linnean tables of the genera and the species to the genetic habit of mind, which sees form as an active process of generation, improvisation, and expression. Here is a second critical component of what will come to be known as ecological thinking, the open, communicative interplay and integration of continuums that possess very different temporalities or rates of unfolding. Every plant and plant part is an expression of one point and moment in this matrix of interactions. So the matrix of interactions is kind of the beginning. It's the first steps toward ecological thinking. 50 years later, by the way, I should have said this at the beginning, the one or two people who will actually enjoy this talk tonight will be the landscape people probably, because they have a kind of a habit of thinking about the vegetal, animal, and say geological and climatological environment in a way altogether. 50 years later, Charles Darwin, in his famous garden at Down House, notices the powerful tendency of a plot of ground, a tiny plot of ground, even a single square yard of turf, as he says, to alter, organize, and transform both the kind and the proportion of elements that make it up. Not only does he posit for us the concept of an active composition, and hence an underlying, if invisible, set of rules and orders, primarily competition, he identifies it as later, but sees the territory in question as composed of communities. Big insight of the early Darwin. Communities held together socially. That's, of course, the community of species. What this concept of sociality, it's a very important part also of ecological thinking, gives us for the first time is an image of an overarching structure or directionality or evolution, as well as the absolutely necessary correlate term, and as the great Ernst Mayr has tirelessly pointed out, a concept that has been almost routinely ignored, even by evolutionary biologists, the concept of the population. Ernst Mayr is often seen to be the greatest evolutionary biologist of the 20th century. either dead or retired now. He was at Harvard for whatever, 30, 40 years. He often argued for population thinking as the great revolution of evolutionary thought. We don't have a clue yet what that really means, even, as he points out, evolutionary biologists don't. Population thinking goes hand in hand with ecological thinking. According to the doctrine, every point and every element in a population, let's say, represents a potential that is different from every other. Indeed, a population is seen as nothing but a field of differences to be realized or not. What is ecological about this is that the differences in the field stabilize into approximate categories, which is what we call the species. For example, you look and you see a whole herd of zebra. What you see is you think is a homogeneous species. And what he points out is it is an absolutely known fact. It's really a kind of a plethora of unbelievable differences. And it's in those differences that what would the word be here? The robustness of the population, the capacity for creative, improvisatory evolution to adapt, if you like, to changing circumstances exists. That's ultimately its resource. Its flexibility lies, if you like, in the way in which it becomes a resource, not a reservoir, if you like, of differences. Now I've gotten lost again. I feel like I'm in that Deleuze class with Isla sitting in the front row. Some of you may know. Nobody reads Deleuze anymore at Harvard, that's for sure. But that he was the great philosopher of difference. We know it's over in a way for that kind of thinking because there's a biography out that just came out on Deleuze and Guattari. Fascinating. There's so many reviews of it. Thank God, actually, that way we don't have to actually read the book, because we don't read books anymore. Hence, the problem that we are facing today. Good, I got that in. Yeah, I got to back up here a bit. Where was I? The species, yes. But the differences in a population do not get extinguished, and the stable forms are at best provisional and illusory. You think you see a herd of zebra. That's not what you see. If you actually could see it, like in the Matrix, you know, where you see all the numbers clicking away, etc., you'd realize you're seeing something, a profusion of potential. Once again, the true reality of what is going on in a landscape is not reducible to what is seen, but to that in the embedded structure that holds it together, to the organization of forces, and especially to the history and the sequence of their appearance in the system. Now, that's another thing that's been hugely underplayed, but it turns out to be one of the most significant aspects about structure and form. The problems introduced by this Darwinian insight have not been widely understood. On one level, underlying instability is endemic and universal. Wherever there is information exchange or information interaction, or actually wherever there is interaction, tout court. On another, the loose confederacies that make up a population represent unities in their own right that interact with other populations, even as they interact with the interactions between their own component elements. So, do I even have, yeah, maybe I got a slide, no. Hence, the principles of modularity. What was that last one? Instability is universal. I really should have had another couple of words in there about interactions, because that is a real key, really central aspect of ecological thinking. Not only interactions of parts, but interactions of interactions. I'm going to skip the part on modularity because that's a whole other thing not necessary for today. Anyway, the concept of modularity, it should be basically some of you are studying it. No, I'm not going on and on about Herbert Simon. Well, it's worth saying that, Herbert Simon. Some people in this room are certainly going to be interested in Herbert Simon's work. It was the last thing he attacked before he died. I mean, it's not like it attacked him back and killed him, but it was very significant that someone of his stature had felt that in many ways the modularity problem was central. But anyway, it should be said it's very widely applied today in genetics, neuroscience, and elsewhere, and it has an extraordinary explanatory power. But to return to the discussion of Darwin's square yard of turf, and it was literally a square yard of turf. What he saw happening in a single 3-by-3-foot little part of his garden was astounding. And I think that's also something, it's the incredible ability to read a landscape of that size. Anyway, I mean, I must tell you, it's like a hunter-gatherer intuition. It's something that we were designed for, but we'll be getting into that in about 2 hours. To return to the discussion, you think I'm kidding, right? To return to the discussion of Darwin's square yard of turf and the principle of history and sequence, ecological structure continues today to be the object of great mystery. In a series of experiments in the mid-1990s by the ecologists Stuart Pym and James Drake on modeling the artificial assembly of ecological communities, it was determined that in such systems there is exhibited a Humpty Dumpty effect. See, you didn't even have to look at that other slide. That was a head breaker. In other words, the Humpty Dumpty effect. In other words, the reassembly of an existing or found ecological community cannot be achieved even if one possesses exhaustive information of the species and the relations that comprise it. See, what happened is they've been studying this parcel of land for years and years and years, exhaustively repertorying and cataloging it, and then a fire hit. The thing was totally wiped out. And then they said, look, we know everything about what was there. And the idea was then they tried to see if they could reconstruct it. And they learned some astounding lessons. An ecological snapshot will not render the movements of a living film. The sequence with which species are introduced, even if many of the species later vanish from the system entirely, continues to structure the integrity of the system long after they have played their visible roles. In sum, ecological structure is temporal structure. I don't get a glass of water. Do you have any water? No. No problem. No problem. No, that would be an interesting limiting factor on how long I can go. There are many episodes of importance in the evolution of ecological thinking between Darwin and Pym and Drake, and many that are not widely acknowledged. I'm hoping as some of you hear this, you're thinking computers, whoa. You know, let me throw this at you. It's a phrase I've used before in other contexts, a phrase I love of Brian Eno. He says, the problem with computers is there is not enough Africa in them. I agree. Tonight we're going to have some Africa. I mean, literally. You'll see, we got a lot of Africa coming. There are many episodes of importance in the evolution of ecological thinking, as I said, that are not widely acknowledged by practicing ecologists. It's worth enumerating a couple, at least, here. I don't know if I'll do them all, but in the off chance, anyway. One that comes to mind, this is worth mentioning, is that of Vladimir Vernadsky, a name relatively known today but almost entirely unknown to English-speaking scientists of the 1990s. When his work from the 1920s was translated into English and came to the attention of people like Lynn Margulis, one of the founders of the Gaia hypothesis, for example. Vernadsky's work was known to philosophers, however, long before. I learned of him in the 1970s through the writings of Georges Bataille, who evokes Vernadsky's concept of an adaptive, metabolic, spherical system, none other than the Earth, driven by that of another, the Sun. And that relationship between these two spheres, Sun and Earth, an astounding one that we began. This is when a certain sense, this is the real origin of the modern idea of ecology. The conversion of energy into structure and into increasingly complex dispositions of matter as this drama unfolds on Earth was seen by Bataille to lie at the foundations of wealth and of what he called general economy. Vernadsky was the first, among many firsts, to understand geology, and later climate, to be driven by chemical and biological activity, and is also the inventor of the concept of the biosphere. It was an astounding idea, actually, to begin to see how these systems, in fact, how geology was essentially driven by life. A final example is the work of theoretical biologist Jakob Johann von Uexküll, of whom it can be said he was the father of the modern notion of ecology. Of preeminent interest is his concept of the Umwelt, the practical world or the environment that corresponds to the sensory and biological endowment of any given organism. So well, I'm going to show you some crazy pictures in this. In this hilarious set of images, try to look at these carefully. I don't know how clear it is. I can't really focus, but from his book on animal worlds, the point is made. The worlds of men, dogs, and flies overlap, but they do not correspond. What you see here is the room according to humans. Well, this is the room according to the dog. So the dog is really basically interested in what he can eat and maybe a few other places that smell pretty foul. The room here, oh, that's the room according to the human. Looks just like the dog's room. And the room according to the fly, yes. The worlds of men, dogs, and flies overlap, but they do not correspond. And yet each not only inhabits its particular Umwelt, its particular environment, each organism is fully continuous and consubstantial with it. That continuity is extremely important as well. In a way, it's the next stage of ecological thinking, is to begin to see an absolute erasure of differences and an absolute commitment to continuity. And when I mean it here, really, it is absolute. The figures in the world that represent assets for the organism, a small fraction of what can be said to be actually, quote, out there, correspond to a sensory system that is both possessed by and which defines that animal. That's what von Uexküll's great innovation was to basically state that that's what an animal is. An animal is a specific world. And the animal's nervous system and those parts of the world which operate for it as signs, or what he called function circles, that defined the animal. That is the beginning of this theoretical biology and this concept of ecology. An animal is a segment of a circuit that connects triggers in one part of the environment to responsive actions in another part. It's really now about the it's about action and response, if you like, and it's happening in both directions, or rather it's happening in cycles and circles. It's merely a more complex and layered part of the environment itself. This is what I call the principle of immanentism, a further central feature of ecological thinking, according to which the distinction between organism and environment, inside and outside, is merely one of degree, a greater or lesser compression or dilation of information or life. And here's where I take a slow swig of the water I don't have. Take a breath and start on part 2. Thank you for that's the theory. That's the theory section. Now we go to now we go on the what's the word? We go on the field trip. I've been thinking about, and in my way studying, I am after all an amateur ethologist, I suppose. I mean, at best I'm an amateur. Studying animals for at least 14 years, the interest began in earnest in 1992 when the National Geographic Organization released the film Eternal Enemies, in which were depicted the most surprising filmed episodes of interspecies interaction, specifically between two distinct families of super predator, lions and hyenas. Some of you may already be seeing these guys, Derek and Beverly Joubert, just came out with a film. I can't believe it. Their latest film on lions. Yeah, how many of you have seen it? Well, I'm psyched. We got 2 hands, really? 3, 4, yeah? Yeah, I haven't yet. They are absolutely brilliant filmmakers. I don't know if lions, it's amazing that it got a release in the general theaters. It's playing in at least 2 theaters in New York City. It's just astounding. But I will tell you this, Lions and Hyenas is hard to beat. It's unlikely that Lions is better than this one. No, but this is widely seen to be one of the greatest nature films ever made. And, you know, well, anyway. At the time of the film's release, I happened to be reading Bruce Chatwin's remarkable study of nomadism called The Songlines. The film study by Beverly and Derek Joubert and Chatwin's ruminative travelogue formed for me a decisive philosophical pair. They struck me as the most significant insights I had come across in years regarding the nature, thank you, of space.
Thank Alan.
Alan. Vodka, I didn't say vodka. We'll get through this lecture, at least I will. Chatwin's book included interviews, incredible actually, with the founder of modern anthropology, Konrad Lorenz, meetings with African paleoanthropologists, and speculations on the predatory pressures that shaped the evolution of human consciousness and life forms. In both works, that's to say, both in the film and in the book of Chatwin, cats and hyenids were pitted together as the foundational forces and fields in which the human type emerged. Some years later, still in full thrall of these 2 documentary essays, I had occasion to travel to Africa with the express purpose to visit the specific sites in which they did their respective field work, primarily to see for myself if what they were proposing as theories could possibly be true. Within hours of my arrival in the bush, after an unbroken 23-hour journey from New York, I awoke from a nap I was taking in a tree. Every time I read this, I think I didn't just land in the tree. Of course, I was put there by guides who knew well that I was safe, but in fact had forgotten to tell me the fact before they left me there, and experienced the most astounding 2 hours of my life. The quiet, almost benign-seeming thorn scrub landscape, with its emptiness and almost infinite vistas, had come to life as I slept, and I was awakened as if by the bustle of a market in a Mediterranean city, by the sounds of a primordial commerce that I knew I had never heard before, but still somehow knew, as if preternaturally. The waterhole next to my tree, which my tree was perched, had become the site of what seemed a spontaneous generation of life. Wave upon wave of animal herds descended in rhythmic turns to the cool pleasures of bath and drink. First the elephants, then the warthogs, the giraffes, the springbok, then elephants again, then larger antelopes and baboons, hornbills and egrets, then a few tentative mixtures of groups in decidedly non-random order and pairings. I couldn't have known that at the time, but one deduces it later. The incredible insouciance and playfulness of the elephants was strictly contrasted with the nervousness of the ungulates, the almost painful contortions of the giraffes, who must spread their legs so far apart to allow for their mouths to reach the water's surface as to place them in grave susceptibility to attack. They must also close the valves in the arteries of their necks so that the immense blood pressure levels needed to carry blood up their necks do not cause their bowed heads to explode. These were my first hours in the African bush, and I still knew nothing about how to read a landscape, but the presence, and this is the point, of multiple pressures and dilations in the environment of behaviors was palpable to anyone with a nervous system. It's a profound intuition that one has, provided you're not panicked and terrified, as some people, no, not very many, but some people just come and they just can't handle it. There's just the memory of that darkness and the savannas from which we emerged, a couple of 100,000 years ago. My eyes scanned the scene in something close to shock. Certainly the procession of forms and fauna was astounding, but what amazed me most was the broad pattern, the deep, almost familiar rhythms of appearance, the immediate way in which my brain began to react by adopting a magical consciousness, taking on the sudden, irrepressible belief, as if you actually believed that the animal patterns were actually being created before me and were not simply being revealed. Some hours later, the guides returned to retrieve me with a thermos of gin in tow, a welcome libation, for at this time I was paralyzed with fright from harassment by a merely curious but seemingly unhinged adolescent male elephant. You don't know that there's adolescent males, you know the story, right? You find, it's the same with elephants. They got big brains and they, if you might say so, they fuck with you because they can. Now, they're scary animals, these elephants. So anyway, I didn't know he wasn't going to push the tree over and crush me to death. But, and he was doing all that stuff, like that kind of. And, I learned a lot later on about how to deal with elephants. Basically, you don't run, but they are fast, huh? Did you ever think about that? 35 miles an hour, an elephant? Anyway, the guides mounted the tree and began to identify the landscape's slower and subtler unfoldings and bass notes. Against the tawny Kalahari dust, and at a distance of no more than 400 yards, they pointed to a dappled patch of stirring, ever so slightly grayer surfaces that were, to the knowing eye, the unmistakable collective pulsations of a pride of hunting lions. The presence and proximity of these predators, I immediately knew, had been the metronome, or better, the conductor's baton, that had both regulated and charged the scene for the last few hours. Every emotion and startle that had passed through me in witness to the flow of Pleistocene life passing before me that amazing afternoon had been a product of sensations transmitted to me within a web of communicative actions and interactions to which, to my infinite surprise, I myself had played an integral part, just as did the pride of lions, despite the fact that I had never been directly aware of it, or in that case, of them. The point, in a way I make about the elephant, et cetera, is that, my presence, they always talk about, what's the word, habituation of animals under these circumstances, but the thing is the biological, the talk that's going on, if you like, is quite intense. And certainly, certainly some of the animals were aware. Elephants, man. It's those big-brained animals you got to watch out for. This, in sum, represented the dawning of a cascade of intuitions that overtook me in the weeks and then years that followed that remarkable afternoon. I have never been able to see space or landscape in quite the same way. Yet I have not even even begun to describe the insight I believe I stumbled upon that afternoon. For in the 3 weeks that followed, and on several subsequent trips since then, I spent each day during the hours around dawn and dusk in active submersion in the environment, actually cognitively hunting, as it were, searching for animals, or as I sort of came to think of them and call them then, as animal events. One quickly learns to search not so much for objects and things as for patterns, actions, disturbances, for a larger modulus of what one could call behaviors. One searches for so many emergences of concentrated intelligibility against the more dilute, or shall we say, the more slowly unfolding and differentiating backdrop of geology and plants. In sum, it is, again, the search for differentials. I would argue, as I've done elsewhere, actually, is that this is what our form reading endowment is essentially organized towards. So our whole capacity to read form really has to do with the distinction and the determination of differentials, most of which, of course, occur in time. The animal, to he or she who adopts the position of the hunter, or the posture of the hunter, and we are all hunters when we dispose ourselves to discern pattern, meaning, and opportunity within the space we inhabit, is a literal byproduct of the environment, an expression of the environment, a literal synecdoche. I know you won't know that word, whatever. A literal synecdoche in which a part serves to represent or express the whole. It's a form of speech. You know, used to study that in structuralist analysis of literature, etc. But anyway, a synecdoche is when the part and the whole. So the point is, what I want to make here is, yes, animal is to environment, what part is to whole, and allow that those terms can also be, they're literal, but they can also be conceptually elaborated, should you wish to. It is within the strange, and in today's world, idiosyncratic posture of hunting. That's to say, the ways in which the hunting impetus has become, let's say, channeled, sublimated, or in some cases erased is another issue. We discover that we too are part of the whole. Here that we come to understand that our animal is continuous with those that we seek and find, and the ones we humans primevally had been required in the name of survival to seek and find. The hunter seeks the animal, seeks to subdue and incorporate it, i.e. eat it, and in the hunting, the animal is often said to migrate into the hunter itself, hence the universal lore in hunter-gatherer societies regarding presentiment. Yeah, I guess this is where the presentiment idea comes from. He calls it Somatic Precognition. This is a book by Elias Canetti, Nobel Prize winner, actually, for his extraordinary novel, but this is an astounding book. The idea of presentiment, the phenomenon through which the hunter is said to feel the markings of the animals he seeks, first as a tingling in the armpits, then as tattoos of sensation drawn on his own skin, was famously documented by Nobel anthropologist Elias Canetti in his remarkable and influential work, Crowds and Power. Khoi and San Bushmen and other hunter-gatherers are renowned for their astonishing ability to track animals and to accurately deduce their actions, their gender, age, level of fitness, maternal status, even intentions and mood from disturbances or marks on plants or in sand or rock. Indeed, this systematic use of the senses to mine the environment has credibly been argued to represent the first appearance of a scientific attitude in human culture. This is the original edition of a very interesting book, very hard to find, but I've been writing to the author, who is now associated actually with the incredible school of biological anthropology at Harvard. He's a South African sort of lay researcher. He's rewriting the book, he told me. It's going to be really incredible. What was I going to say about the guy? Oh, yes, he had won a Rolex prize, fantastic he won a Rolex prize, not a Rolex watch. He won a Rolex prize for some astounding work that he was doing, giving very simple computers to Stone Age hunter-gatherers who have this unbelievable ability to read the environment. And what they would do is they would just enter things when they saw animals, and the data was being uploaded and then downloaded to Waters Rand University. And they were actually they were mapping out landscapes and patterns. I mean, it was an amazing ecological study. And it's still ongoing, actually. These guys walk around and they just punch things in as they see them. And it's collecting a kind of data that has never been collectible before. But anyways, tracking, I think, is just an incredible use of the human brain, the human nervous system. Consider the following, the opening passage from a treatise on tracking by a contemporary American wilderness guide. The first track is the end of a string. At the other end, a being is moving, a mystery, dropping a hint about itself ever so many feet, telling you more about itself until you can almost see it, even before you come to it. Now, this has been studied. I want to say another thing is that I don't have an example of it. I don't know why I don't. No. There was a film made about 7 years ago called The Great Dance, in which they actually filmed what is known as a persistence hunt. A persistence hunt is when a human runs down a huge animal like a kudu to the death. It can take up to 7, 8, 9 hours of running in 140-degree heat. And what is interesting about this is that there's a lot of speculation that this was the original form of hunting well, I'll be going into this a little bit more, but what's fascinating about it simply is that this new work being done now on bipedalism, etc., it turns out that the human can outrun any animal on Earth. We are, in fact, a running species. And when I say outrun, it doesn't mean in a short run. I mean, that elephant's going to get you in the short run, as we described. But if you need to run down another, and there's no animal that can run as long as a human. One could say that a fundamental scientific insight was achieved in the 19th century by the French. Who cares about this? No, I mean, it bangs home the point simply. You know, this is Michelet, right? He writes that the bird cannot be thought separate from its nest. And it's the same idea, the same ecological idea. Similarly, what every animal teaches us, and I use the word animal here to refer to the capacity of any living process to mark or transform its environment, is that the animal is what makes space something rather than nothing. It is what determines the positivity of space, even in the absence of concrete forms, what determines its capacity to organize, to affect, and to move. The animal is this in two ways. First, because it represents a condensation or a contraction of the relationships in landscapes, climate, geology, vegetation, history, relational webs with other animal forms, etc. And secondly, because endowed as it is with capacity to move and energy to expend, it represents a volatilization of space, an instigator around which space and being happen and unfold. This is precisely, you're going to wake up now, I promise you this. This is precisely what the philosophical anthropologist Georges Bataille sought to express when at the beginning of The Accursed Share, he declares, the sex act is to time what the tiger is to space. Both are forms of prodigal combustion. I guess this is the thing you're going to remember from this talk. Write it down. No, I really recommend you write it down, because you can say, what the hell did he say again about sex? No, but this is very, very deep. This is very, very deep. I'm not going to explain it to you either. You've got to go out and figure it out. Now, when I say combustion, I mean precisely that, and in two ways. When one burns or combusts a log of wood, one harvests the potential chemical energy invested in it by the life of the tree that gave it form. In many ways, here we're getting into the webs, if you like, and the webs and the transfers and the transformations. And in many ways, this economic relationship is the same one Bataille spoke of when, following the work of Vladimir Vernadsky, he described the Earth's system and human civilization as a direct extension of Earth's geochemistry, as one of managing and administrating the sun's energy, both trapping it in stores, i.e. in plants, as well as expending it and letting it go free, for those of you who are interested in Georges Bataille. I want to point out, this is the book, yes, that you can't see it all that well. A book, I got it off of Amazon. I needed the image, right, so it just is not that good an image. But this is a zone book, and we designed this book. The cover, you can't see it. I mean, normally we designed our covers so that the full image would always be visible when if the thing were opened up. But what you should know is that the idea, this is the work of Georges Bataille called the accursed share, is that it's the picture of sun storms. It's a huge partial picture of the sun. The second way has to do with the harvesting of a different type of order, that which we call information. The landscape in its entirety is a dynamic material world and is a product of invisible algorithmic forces and logics that shape and direct it in accordance with and in accommodation of all other forces and logics present within it. When we study these relationships with reference to the forms that they produce, we call it evolutionary theory. But we also, and increasingly, call it ecology. This connection, I would argue, is extremely profound, still incompletely acknowledged, and paramount. It is one that it is necessary to adopt today. We're about halfway through. Not really. It's a kind of a trick to get you to, get through this. I love this stuff. I gotta tell you, I love it. And yet, animals do not study evolutionary theory, nor do the human cultures whose livelihood depends on hunting and harvesting them. Rather, what animals and hunters do is enter into communicative webs with one another. Since they must either ingest or evade one another in order to survive, they must attune their nervous systems to one another's actions. And that's an incredible practice, if you think about it. Remember, that's the work of evolution, the attuning, the constant calibration to the nervous system of another being or to the environment itself, and particularly to one another's actions on the environment. One example, I think of an anecdote here, and that is when I was in Africa and I was, trying to hang out when I could with hunter-gatherers, particularly the San Bushmen. They still sometimes hunt. It's rare, but they know how to do it. They still have living people who still know the old ways. They have this idea, which has now been tested and proven. They had this idea is that you mustn't let the flies land on you while you're hunting an animal because it can carry the scent of your sweat to the animal you're hunting. A fantastic idea, but the point is, there's all these kind of, plus the way they read the birds. You'd never want to disturb a bird when you're hunting an eland, because the eland is attuned to the bird. Such as also, I could go on, I love these stories. The great tsunami, not the recent tsunami, but the older tsunami, when the Andaman Islanders, again, these were actually a pre-contact group of hunter-gatherers, people who've had zero contact virtually with the so-called civilized technological world. They were thought to be entirely wiped out in the first days of the tsunami. And of course, later they found out that they all survived. And the reason, of course, is like, how did they know? What is it? These people have, like, is it magic? That kind of new age thing. Oh, they knew tsunami. Well, no, not at all. When finally, in a way, when the inquiries were made, well, how did they know? Well, the first thing that happens, you see, is the fish start acting weird. Because they sense the changes, if you course, in their aquatic environment. Now, the change in behavior of the fish result in the change of behavior of the predatory raptor birds. Those, of course, are immediately observable by land animals and also large-brained land mammals like the Andaman Islanders. The precise chain of interactions, but the point basically being is the attunedness, if you like, that is, necessary. It's something that is, something that is almost empirically verifiable. This ancient biological tuning, too, is a form of tracking, a form of knowledge practice, a form of combusting the legible organization in the environment, form reading. I want to argue here it's a form of informational combustion. When two animals are locked into an evolutionary struggle with one another, say through the competition for the same food resources, or as part of a predator-prey relationship, we say that an arms race occurs. For example, millions of years ago, when the earth warmed and many climate systems dried up, grasslands replaced much of the forest cover. This gave rise to the first mega herbivores, huge animals like today's elephants that graze and concentrate huge portions of the landscape's flora and plant bounty into its body in the form of meat. As the rule goes, where there is prey, there are predators. Where there is energy, there will be combustors. Thus, saber-toothed cats evolved specialists of a specific type of thrashing kill, to which the mega herbivores were vulnerable and the cats thrived. It's fascinating to think that even, here all throughout this whole area of California was full of these guys, these saber-toothed cats running around. Soon, new species of hyena arrived on the evolutionary scene with totally different behaviors, with the emphasis here on the behavioral complexes, to scavenge the remains of these kills. When humans arrived sometime later, the mega herbivores were a prime and viable prey, and the famous cerebral and social efficiency of the humans ultimately denied the saber-toothed cats the only meal they were adapted to procure, and they soon died out. What essentially happened is the generalists arrived. The hyenas, generalists that they are, were more versatile, and so began to evolve in a new direction toward accommodation of the new species imposing on their habitat, i.e. humans. Here, the webs of influence and communication are largely imperceptible, or shall we say they are embedded. They take place over great periods of time, are not available to perception or discernment within the attention or even lifespan of a single animal, yet the efficient transfer and circulation of information takes place regardless. The world and the species that make it transform. Now, ultimately, the point of some of what I'm trying to say here is that these are empirically, these are simple facts, and from those facts, a certain number of hypotheses can be drawn. One thing we know is this form process, this design process is real. It does take place, even though there's a lot of controversy about exactly how. This is one way in which the landscape is continually harvested or combusted by animal continuums. But it is not food and the energy stored within it that is in play here, but rather the economic information produced within and distributed throughout the broader ecology. That's to say, the economic information is really what we need to understand now. Now, I want to remind you, I'm talking about ecology and ecological thinking. So the problem of form and, like I say, these economic information. There are many forms of environmental combustion. Two of the most important really are teeth and brains, the evolution of those particular forms. I'm going to focus on brains mostly, but although, okay, let's start a little bit with with teeth, and we'll move on to brains. Teeth may very well, even though I'm going to talk about brain, they may very well be the most important one, the most important determinant of an animal's life and culture, or that's to say, of its Umwelt. Teeth determine not only what an animal will look like, how it will socialize, how large it will be, and what other animals and forces in the landscape it will relate, what types of behaviors it will evolve, but also teeth are the principal determinant of what part of the landscape and in what modality the animal will seek to combust. For example, the saber-tooth, it had one modus, it had one module, what would the word be? Modulus. It had one way to kill, if you like, and therefore there were a certain type of animals that fit that modulus, and that niche was very narrow. Teeth tell the whole evolutionary story, which is why, in fact, paleoanthropologists are so focused on teeth, and why when you find a single hominid tooth in Chad, you can paint the entire civilization of which the particular hominid was part. And nowhere more dramatically than in the ecological transition stories of ape to man. Teeth also tell the broader story of the evolution of vertebrate predation and the general distribution and parceling of resources in the environment. There is no flower, for example, that has not incorporated these often sanguine and violent stories and scenes. That's to say, the impact, the way they scale through the environment. Let it be said that the story of teeth, perhaps the most detailed lesson in adaptive form that we have, of which a single chapter, for example, would be the emergence of the Carnassial tooth that gave rise to the omnivorous combustors. The Carnassial tooth is a shearing tooth that apparently is what changed the whole landscape, and I mean even literally the geology, which made the generalists possible. It's the crushing tooth, and it's also the tooth that can slice meat very, very quickly, whose lifestyle versatility, the Carnassial was the foundation, if you like, of the generalist possibility, of the animal, if you like, that could adapt to a wide range of different climates and habitats. Created the ecological opening to allow evolution to bear no further on major body plan issues, but at last on brain development and neocortical plasticity. This is where the issue of the brain comes in. Let me just say that part. I mean, I cut some stuff out. The idea here is that simply once this great tooth arrived, the rest of the animal did not have to evolve any further. It had this unbelievable capacity to adapt to a wide range of habitats. Suddenly, the issue of the brain becomes central. Large brains, especially, large brains are clearly enjoyed by most of the animals that own them, but the fact remains they are extremely expensive. Well, they are. They're bloody expensive. The amount you got to eat, it takes up whatever, 30, 40% actually of your caloric intake, etc. For not only are brains extremely expensive to run, requiring a great deal of high-quality food to power them, their high metabolic rate makes them prodigious producers of heat. And so they are also very expensive to keep cool. Brains are made up of exquisitely sensitive tissue. Even a 4-degree rise in its temperature, centigrade, is likely to result in death. You can't have a big brain without a very sophisticated cooling system. But as the newest stories about co-evolution, this contemporary stories, the last few years, of landscapes and organisms develops today, we are also learning that climate change, the thing that we're also supposedly worried about and supposed to think through, specifically the dramatic heating up of the environment 4 to 5 million years ago, was a prime cause, or was it a precondition, of encephalization and hominization. The massive brain that we developed really had to do with heating. I'll explain that in a minute. Or rather cooling. Or rather heating. Cooling was the problem. Heating was the impetus. As the environment got hotter, it also got drier. At least in Africa, where it mattered most in the late Pliocene and early Pleistocene, causing forest habitats to shrink and savannas and grassy plains to flourish. So the landscape is changing because of the climate change. Apes, as the story goes, needed to find food out in the open, a dangerous place fraught with seasoned predators, and so required an advantage of some type to protect them. What they got was several interconnected ones, or several interconnected adaptations. Well, what's new? Of course. It's the interconnection that's so fascinating. It's a real parametric procedure. The first set of problems requiring solution was how to move quickly through the dangerous open spaces while carrying one's young. This problem was said to be solved by upright posture and the freeing of the hands for novel uses. Not only do you use them to carry your young, but you can do a hell of a lot with your hands once they're free. With a new set of ecological potentials for the hands, freed from locomotion, that thing, that brachiation that most apes do, or not all, most, all apes do, came new cultural possibilities, hence the central problem of hominoid and hominin ecology, the concept of culture, the emergence of a culture, for example. Freed hands provided an opening, perhaps even a demand for a new and enlarged brain to program them, and hence the rise of what is known as the tool industry, the ability to actually fashion tools that could then be used, if you like, to effectuate certain other transformations of the environment. But the new environmental heat, and I'm talking literally the heat that was coming from the sun, placed unprecedented stress on the animal to keep cool. A large, sensitive, heat-producing, and expensive brain, sounds like a girlfriend in a way here, a large, sensitive, heat-producing, or the opposite, whatever, you know, a large, sensitive, heat-producing, and expensive brain represented a dangerous added burden, unless a highly innovative system of cooling could be found. Among the arguments that I find interesting today have argued that the invention of a novel air conditioning system constitutes, I'm not talking about, you know, HVAC, obviously, but internal, anatomical, constitutes the defining feature of, and even the evolutionary impetus behind the emergence of the human species. Because humans have large brains, short faces, and special teeth, all effects of the environment-derived pressure to change diet, and hence modalities of combustion. You see, all these things have to happen all at the same time. You can't chew nuts and berries and power the brain, or not entirely. So anyway, the whole story about vegetarians, forget about it. Now, no, but I mean, absolutely forget about it. Now, don't trust me. Read this incredible book by Richard Wrangham, who relies, obviously on the same references that I'm going to be talking about now. Richard Wrangham's book that came out a year and a half ago called Catching Fire, it's hilarious because the first part of the book is not very good, but it's like a diatribe against vegetarianism, or really against the raw food movement. He just shows with scientific data that raw foods will, it'll end the human civilization really within a few years. The first thing, it produces amenorrhea, and then that's the end. Now let's get back to the air conditioning system for now. So the whole problem, we get the nice face, the nice face that we humans have, not that ape face. We do not possess a snout. That's a problem. It's not a problem for, hanging out in a bar. It's a problem for cooling. We lack the hollow nasal chambers and the venous adaptations in the head that most animals use to cool the blood that feeds the brain. Snouts are basically radiators. If apes aspired to compete in savanna habitats, they were going to require innovative adaptations to manage the heat stress that came with the environment. All other savanna mammals, every other one, uses selective cooling based on the protruding face, the hollow snout, and the carotid rete, which is a kind of an organ in which blood is pooled in the face, in the sinus area, and sometimes in the neck, for cooling before it's allowed to go up into the brain. Otherwise, the brain cooks, it's all over. Humans cannot do this. Their brain is proportionately too large and would require a neck as wide as its thorax. And it's funny when you say this at a university, not this kind of a school, but you think, oh yeah, that's like the football team. And you think it's not impossible that we could evolve a neck, like this, and which you could use for cooling, maybe. Anyways, the point basically being what is general cooling is they have to use their full body. You have to have a system of full body cooling. We're the only animal that has it. The first adaptation toward this end is said to be the achievement of upright posture, which has been calculated to cut heat load by more than 30% by exposing far less of the animal's body. We shouldn't talk about humans or early humans as animals, but whatever. Yes, we should. What am I saying? That's the whole point. We're animals. We evolved. We're not creationists. Far less of the animal's body surface to the direct rays of the sun. Now, this has been measured. You guys, even in the sustainability classes, they do all that stuff, and they figure these things out, and it's fascinating. It also moves the brain and organs away from the ground surface where temperatures are significantly higher. Now, that's astounding, how much hotter it is 1 inch above the ground. It's just, the gradients are unbelievable. The second is the shedding of the fur covering, the development of naked skin, and the profuse sweating that permits ultra-efficient radiation of heat through evaporation. But this last adaptation, for this last adaptation, the animal would require regular access to considerable quantities of water on a highly regular basis. It's a simple fact that we are intensely dependent on being able to access water every X number of hours. Without that, 2 days, and you're dead. Now, this is a very interesting thing. Those of you, of course, who go to the desert know the rule. You never go anywhere without water. You can live 2 days, but maybe you'll start hallucinating after the first. The point is, though, it's a very important thing adaptationally and in the early environment. You got to remember where the stuff is. You got to start tracking. It's a different relationship to the environment to be constantly keeping in touch with where the sources of water are. The increase in travel range and the size of hunting and scavenging habitat was an important result both of the entirely novel form of human bipedal locomotion, which is incredibly efficient, as I've already said, and the cerebral cortex used in calculating interrelationships, navigational and otherwise. So the cortex is an incredibly important development. We're the only one who has it to such a degree, and super fascinating. I've read that apes and baboons never leave their home range. You can chase them, like you can blitz them, and as soon as they reach the end of their home range, they will stop and turn around. They will not leave, even chimps, they will not leave their home range, despite the fact that their stereoscopic vision allows them to see great distances. It would seem that humans are the only primates who can and do go where they see. Humans are the only ones who actually adventure off and check out what they see, you know, far, I mean, when it goes beyond their home range. So the relationship to the landscape is very different, if you like, in our evolution. Whether it is brain capacity that delimits their psychogeography, as some researchers have argued, well, anyway, only future research and speculation can answer. But water resource management is clearly a very different affair in highly encephalized mammals. It is cognitive and not only perceptual, as even I have observed in the field, such as in elephants. Elephants memorize where the water is. It's not a question of being able to sense it. They know where it is. They remember it for generations sometimes. They even hand down the knowledge in certain ways, but it can be years later. They know where to go. It's not like they can sense it. They know, they remember. It's a kind of a collective history. What we encounter here, and at every level and turn, is a whole modulus or network of relationships and especially forms, each changing in collaboration and communication with the others. But there were other, more internal and less visible transformations that matter, ones involving feedback relationships. Among the most important is how the emerging human form and the human cultural type managed not only its heat budget, but its metabolic budget as well. If the brain is made up of expensive tissue that requires a great deal of extra calories and water to maintain, it is also true that no animal could maintain such a high maintenance economic life if it did not have a very large brain. So you see what happens is the brain gets bigger and makes greater demands, if you like, on the culture of the animal, which in turn requires more brain, if you like, to manage, et cetera, et cetera. So essentially it's like an arms race that's taking place internally to one animal. But more basic than this is the way the body itself sought to balance its books. It's been widely noted that the human gut is very short compared with that of other mammals for its relative size. Indeed, it's half the predicted length. In addition, physiological studies show that the intestines contribute as much or more to an animal's what they call their basal metabolic rate, which is the rate at which the animal combusts energy when it's at rest, than does the brain. So bottom line here is, they always say the brain is really expensive. Well, the gut is very expensive too. And the fact of the matter is we paid for the brain with our gut. Intestines are very expensive tissue. The massive increase in human brain size, according to a widely discussed theory, was thus balanced by, it's not sure, this is just an interesting theory, balanced by a decrease in gut size, and this had definitive repercussions on every aspect of the human world. The first and most basic effect was to require a whole new approach to eating, and this is where Wrangham's incredible book has a lot to do with. The absolute requirement for very high quality, nutritious foods that can be eaten in small quantities, but at frequent and regular intervals. This meant highly selective foraging and judicious identification, particularly of reproductive organs, the most nutritionally dense part of the environment. I mean, it's what humans had to do, is seeds and tubers, nuts and eggs. Steal them, get them anywhere you can. It also meant procuring protein and fat in the form of meat. When you read Wrangham's book, it's fascinating to see the degree. You will die if you, I mean, for those of you who basically think, okay, no more vegetable, I mean, no more, purely, or less raw foods. One of the things that really becomes very interesting is the requirement for fat. I mean, you need fat more than anything else. Don't eat meat when you're starving in the desert. Get fat. I mean, really, it's astounding, the requirements for the body's metabolism. An activity requiring immense, this kind of hunting, being able to procure the specific foods. Now remember, think about what the brain has got to do to base that new level of refinement that is required, requiring immense adaptations for strategic hunting, which included the need to act in coordinated and cooperative social groups, and even, as researchers have recently begun to speculate, to the rise of the family group and to the particularities of those age-old relations between the sexes, something that Wrangham enjoys and others going on about. What was I going to say here? Yeah, the rise of the social carnivore. Most of the biological textbooks now refer to humans as social carnivores, part of a group, and no longer as essentially as high-class apes, in the sense that our lifestyle is far more to do with those of the animals with which we shared a habitat for 98% of our evolution after branching off from the apes, essentially is lions, hyenas, and the wild dogs, the astounding hunters of the wild dogs. It's a whole other story. But the bottom line here, and I realize I do have to conclude, is to affirm that the large brain is at once directly and indirectly a product and an expression of climate and ecology. It emerged as a response to an increasingly hot and dry environment, and in tandem with the evolution of a novel and biologically unique cooling system. But once the movement toward encephalization or big brainness began, a broad set of other regimes necessarily were triggered, based on the need to extract from the environment the resources to keep the brain running. Human life, the human physical form, including our beautiful faces, flat stomachs, dexterous hands. You laugh, but you ever see a chimp's belly? You think about that, right? You think about, you ever think about, we now know that Neanderthals lived side by side with Homo sapiens. So like what went on? You ever think about that? Like, hey, No, but I think about that all the time. I think, what does it mean? What does it mean to go over there and, chat up the Neanderthal? But you have to realize, there's a whole physical thing that's here because, chimps have a huge gut. They have the full expected gut. We don't. And the whole thing that we see is, what I'm saying is the humanness and the aesthetics, et cetera, is a critic. I mean, remember, it's through aesthetics, in case one actually needs to say this, that the whole capacity to choose a mate and it's the importance, if you like, the fitness issues have to play in. So, I mean, to divorce those processes, those hardwired capacities, if you like, from the way we understand the things that we do, buildings, objects, design, et cetera, would be a great mistake. So there we go. Our subtle humor as well. Again, a kind of a product of the prefrontal cortex, the massive cortex. Our complex behaviors and our notable species achievements, such as language, technology, and culture, may be little more than ecological responses to the broader and more mundane economics of satisfying the dietary and ethological demands of a large brain. From this foundation, From this foundation, the entire human relationship to the environment was forever determined. Encephalization, one could argue, was not in itself driven by any need or desire to break off from the animal evolutionary tree in the direction of culture, language, but as a direct result of climate change and triggered by the invention of a novel cooling system, followed by the requirements of food procurement and the management of interspecies threats in a new ecological niche and in a new landscape. These latter forces imposed on us the need for ever more subtle ways of reading, remembering, and interacting with the environment, discovering ever new opportunities within it. If we are human, it is because this science of the environment, empirical and intellectual combustion of our surrounding world, was forced upon us, and it is the source of our very human genius for formal and technical invention. It's not over. I'll leave my talk off here. In my closing 90 seconds, I would like to present to you some images from an unusually remote tribal world in the Omo Valley. Some of you will know these. In the Omo Valley of southern Ethiopia. Aside from the obvious lyrical beauty of the images and the social practices that they reveal, one will see an uncanny demonstration of many of the themes presented in the last hour or more, in which social and corporal practices extend seamlessly into the natural environment through a play of incorporation and annexation of the surrounding plant and animal world, which is not unrelated to the practice of eating, nor to that of capture or hunting, nor even for that matter, nor is it unrelated to evolution itself, but which has, in the case I will show you, been sublimated into symbolic, aesthetic, social, erotic, and even musical improvisatory activity. Through both crypsis being the way in which some biological species hide, so to speak, in the environment by mimicking the environment around it, and mimicry, and in undeniable echo of the somatic precognition that Canetti described with respect to the Bushmen of the southern hemisphere, that incorporation and making oneself continuous, if you like, with one's environment and the other forms in it, or playing it out, as you would. The landscape and the extended living world is here made to propagate over and through the body, to undergo continual transformation and especially communication. That's what ecology is about, communication in the process. And it is perhaps important to add that it is said of these people that they do not possess, nor as a rule have they ever even seen, mirrors. Now I got to think, we may have a problem with the sound, but
Yes.
When you were talking, or when you were telling your story about being stuck in the tree, it struck me that it seemed a lot like in Deleuze and Guattari of becoming maybe afraid of the edge of the cliff, as he tells in the book. Maybe how an animal becomes afraid of the cliff, but because you're in this web of survival, you started to become vulnerable. I was wondering if you could talk about that a little.
I don't remember this story of the edge of the cliff. The becoming, you know, in a certain way, there's a... Look, in a way, it's... If I were to relate this to Deleuze, I would say the big lesson here is it's not about becoming animal. In a way, it is understanding the degree to which one's connectedness to other animals is primordial. What I mean by that is, you know, there's this, the formulation that I said about the human being more closely related to the hyenas, the social carnivores, actually, of the savannas, was a hypothesis that was put forward by the two greatest animal ethologists and anthropologists of the 1960s, Washburn and I think it was even Schaller. What's his name? Does anyone know these guys? I forget Schaller's name, but he's the king of animals. He's still alive, actually. These guys went out one day in the savannah in Kenya, and they decided to give up their Jeep and all their equipment, etc. And they said they're going to spend the next few hours hunting with their hands. These are like, you know, guys from universities, right? You know, these are guys, professors who, you know, if they're lucky, they spend 80 days in the bush. And they just said, let's just see whether it would be possible that you know, the hunter-gatherer humans could actually do it. And they spent 2.5 hours, you know, subjecting themselves in a certain sense to the dangers of the savannah as well, because they were also prey animals. They determined that it was indeed, you know, a possible hypothesis. Now, when you get to Canetti, the incredible sections when he talks about somatic precognition, it has to do with the stories that were first collected in the late 1890s and, well, the late 19th century, when the first Bushmen were essentially captured and thrown in, essentially in camps, concentration camps in southern Africa, and then jails. They had all these Bushmen in jails in southern Africa, and these anthropologists, Dorothy Bleak and her husband, interviewed them, and it was you know, they did a systematic recounting of the experiences of what it, you know, essentially of what their lives were like, and it's the first time that one actually recorded these things, and Canetti's work was done on the records of the Bleaks. I mean, he did the work probably in the 1960s, and he was essentially analyzing the work. But the thing is that, you know, even today, even if you see this film, the Hunter, the Great Dance, hard to get, but I hear I can hear it's actually available online. You can just click and watch it on your computer. You will actually see people as recently as 1992 who absolutely undergo this transformation, and something astounding happens in the end of the film, meaning lore for 100 years states that the animal will render itself to the hunter. Now we know that, well, I mean, and what happens in that is the eland, which is a massive animal, an unbelievably powerful and rare animal, they just run it down. 7 or 8 hours, they run it down. These guys, who knows how they do it. The animal in the end, and you see it on film, turns and steps up toward them and basically renders himself, if you like, to the hunters, who then respectfully put it out of its misery. Of course, what we know is that persistence hunting basically boils the animal's brain. So the animal becomes delirious at the end, and no longer, it's a kind of almost a rabid state where the animal no longer has any fear, if you like, of the hunter. But nonetheless, the fact is that the postures, the modes, and the forms of position taking vis-a-vis the environment, you know, these things worked for hundreds of thousands of years. What I mean by that is that it is not strictly speaking what they say it is. You know, they don't actually feel the animal. It's not the actual animal stripes which they feel on their neck, or they can feel the blood running down their legs, nor is the animal actually rendering itself. But it says that these attitudes toward nature are what allowed survival, if you like, and they were empirically they were a form of science, if you like. Now, by the way, one thing I should say about this, it's not just different ways of looking at the lore, you know, of the way things were done for, you know, 200,000 years, and now we got science. Oh, we straightened the whole issue out. In 1991, P.T. Stander from the University of Cambridge did a study in Africa where what they did was they videotaped events that took place in the bush with animals. Usually it was a hunt. And they would bring in these San Bushmen up to 48 hours after the event was filmed. So they have a complete scientific controlled study. They would bring them in to interpret the remaining signs. Now remember, 48 hours of disturbance of the environment would certainly change a lot. They would come in and they found that they had 98% accuracy in terms of describing exactly what had taken place in relation to, you know, what kind of animal hunted what other animal, what state the animal was in, which leg was lamed, what event occurred, how the animal got away, how it got caught again, the whole thing, 98% accuracy. So what we do know is that there are different attitudes, so to speak, and postures toward the environment, but we also know that this is a it is something from which, if you like, today we have become, well, most of us no longer even believe it. I say most of us scientists, etc. And it is something that has a it is something from which we can really learn, if you like. There is something extraordinarily radical in it, and I think that in many ways it has a lot to do with the types of scientific attitude that have been cultivated for the last 20 or 30 years in other areas of physics, you know, complexity theory, et cetera, et cetera. You know, now you get into dangerous realms here where it is hard to separate the things which are fact from those which are not. But I think it's an area that we need to begin, you know, if you like, to look at. So the question is what was my transformation, what anyone else's is? There is an undeniable aspect of the fact that our nervous systems belong to that environment. You know, we have lived for barely 20, 21, 22,000 years outside of a hunter-gatherer environment, where our relationships to animals and plants, etc., have, you know, been completely transformed. And now, of course, frankly, we have to admit something, is that the flexibility, the incredible plasticity of the human brain is now being put at the service of software, of responding to movement cues on a screen. In many ways, it's tapping into the deepest, most pleasurable hunting and predator-prey reflexes for which we were bred. And, you know, we have to ask, you know, are we going to accept our position as prey animals in a new technological savannah? Maybe we don't have to. That's my answer.
All right, so yeah, thanks. Sustainability. You introduced your talk with that. You said that you're greatly disappointed with it. I tend to agree. I would argue that sustainability is a form of adaptation, potentially. But have we demonstrated an ability to adapt preemptively and in an anticipatory manner? Because I would say that the cues aren't really there for me personally to adapt. I'm getting fit with some effort. I'm maintaining shelter with some effort. But it's happening. So I don't need to change the way I live. I don't have to recycle. I don't have to alter my form of habitation. So what will compel us as a species to adapt?
I know. Yeah. It's fantastic argument. very sophisticated that actually thought this is absolutely the kind of arguments that biologists make today. It comes down to the very classical problem in evolutionary theory, which is often called the altruism hypothesis. Now, everybody's playing around with it. We don't know if altruism really exists. We do find certain mechanisms, such as certain animals that pronk, leap up into the air. Essentially, what you find is in some herd animals expose themselves to danger to an oncoming predator in order to signal to the rest of the herd that they should leave. But in a certain sense, what they are doing, of course, is increasing their own risk because it preserves the species. Now, the whole issue around altruism is that if it exists, it's because there is this kind of group selection, population selection, species selection, band selection, etc. Now, you know, we don't know the answers to these things, but on the other hand, we're humans. We're not zebra. We have a narcissism, if nothing else, about the accomplishments that we have produced, let's say, collectively to date. We have an incredible awareness of death. We're the only animal, probably, well, we're among the large-brained mammals, if you like, who are acutely aware of death and even rendered neurotic by it. With that fact, with the fact of our narcissism and with the fact of our awareness of death and mortality, our intense desire to be, what is the word, immortal, I guess, we really do have the capacity, I would say, to think of these types of civilizational adaptations as mortally as imperatives that we would have to follow. Now, you also bring up another big issue, which is simply, sure, Kwinter, great, interesting answer. Obviously, that ain't enough, as we know. I mean, the way in which economic life takes place in those parts of the brain that run this country and most parts of the capitalist world, etc., it's pretty damn unlikely that until it costs too damn much, anything is going to really happen. But they're around the corner. Those things are around the corner. The so-called, what did I read? The so-called climate, what do you call them? Climate refugees. We're going to see them. We're going to see them in 10 years. We're going to see, huge parts of, of the Earth's geography are going to be abandoned in very significant numbers because it's no longer possible to live in them, et cetera, et cetera. So, I mean, the costs are coming. At the same time, I would like to be a kind of, great advocate of sustainability because in a certain sense I am. But when you ask what are the mechanisms, I don't think we're looking at brute adaptations. We're not looking at instinctual, altruistic, and sensible behavior. We're looking at something that's the product of specifically human civilization. It's the product of our prefrontal cortex that is going to make us do something or not the, not to say it's not our reproductive organs. So I don't know the answer. This is the answer for philosophers, economists, et cetera, et cetera. But what I do want to say is that it's not a simple adaptation, like you say. Where are the incentives? Do we absolutely need incentives, or can reason alone change the path of civilization? Personally, that every day I get older, the less likely I am to believe that, the answer to this is. I become increasingly pessimistic about that. But one thing is, things change. They will change. They will change. We talk about this, we try to change things, but there'll be some big ideas. Look, nuclear energy, that might be over now. Man. We haven't seen what's coming. We haven't heard the last of what's happening in Japan. These disasters will change what we do, and these disasters are coming at an incredibly quick rate. It's also true that how many tsunamis have there been in the last 3 years, 4 years? 3 at least. I know the one in Peru, the one in Japan. Those are the things that change us. You don't change little by little. You don't evolve slowly. As the number of catastrophes just become too great, and then certain adaptations happen. So look, I don't know the answers. It's a great question. I would say it's a great question, and I would say again, the evolutionary thinking gives us great sort of guides for how to think these things through. So, I mean, I just think it's worthwhile to add to the toolkit.
In relation to prehistoric human evolution, how do you see human evolution now in the context of civilization and contemporary?
Well, you know, I really wish I was an expert. I really wish I didn't have to teach classes on the things I do teach, because I really am interested in this. But one thing we know is evolution is happening now. I used to think, oh, it's over because everybody gets to breed. But it's not the case. It's really complicated. Well, more or less, right? Because that's what happens. The whole point is being eliminated from the breeding population is essentially what causes, you know, strict selection. One thing that comes to mind is when they were studying, microcephaly in a particular set of towns in Pakistan, where there's a great number of what used to be called, you know, pinheads, you know, very microcephalics. There are families with 6, 7, 8 microcephalics in it. So, I mean, some biologists went down there to study it, and they really went deep, and they really found the gene that is causing microcephaly. What they discovered was that the gene was not really a gene for microcephaly. It was an inhibitor for something much more interesting, which is the large brain gene. And then what they discovered in their continuing, you know, analyses, genomic analyses, is that the large brain gene is already, it's only something like 120 years old, and it is, you have to have 2 to get, but the point is that it is, in 20% of the population have it today, and it is just moving through the population. So we're actually continuing to select for larger and larger brains. And those are just some of the, you know, the discoveries that are coming up. And there's new books out too. There's books that have been written that have come out in the last 6 months about you know, one thing that was interesting about the creationist, you know, the big debates that happened in the late 90s and the first few years of the naughty, what do they call those, the naughties, whatever, the first years of the 21st century. I know, the British call it naughties. I don't know why. I guess everything's naughty to Brits, but anyway. The creationist debate, by the way, is over. And if anyone wants to challenge me, I'll see you outside after this. But the creationist debate is over. I mean, it's gone. Nobody's going to answer the creationists anymore because it's all been decided. Evolution is no longer a theory. It's now a science. And what was very interesting about that is it really fine-tuned evolutionary theory, and it really cleared the table. So a lot of incredible work is actually coming out now. I mean, it's a fascinating idea, the fact that we're still evolving. What are the mechanisms? The mechanisms aren't only, that's the other thing, they're subtle, it's incredibly subtle. It's not only, you know, natural selection. There are other mechanisms that have been started and which still have to play themselves out. Now, who knows? Who knows? Who knows? You know, the point is we're not so civilized that we're free of evolution. In fact, we should be, you know, we should celebrate the, you know, incredible, woo, oh, you're cutting me off now, the incredible diversity and potential diversity that we have in our populations. And of course, at some point, we'll realize that it'll become a political issue in the sense that maybe, just maybe, the state organization, the state formation, just maybe it will become weakened, if you like, because of a strengthening of different types of social mechanisms, if you like. Now, those things are certainly within the possibilities. So we don't know what humans are. We should try to keep open about what's possible and what's not. All right. I'm going to try to make a really short answer this time.
Early in your conversation, you threw the word of computers. I was just wondering if you could elaborate more on this. Towards evolution, what role is this new ecology of machines going to play in the relationship of us with them and the environment with them?
The question is, you should do it. Another thing that I like to study is this thing called neural plasticity, which has to do with all of the ways in which the brain is continually capable of adapting and resculpting itself. And there are all types of constraints and parameters that fall in that, but it's astounding how plastic the brain is. Astounding how much it can be changed right through adulthood, right through to the, into your 70s, in fact, and your 80s. One thing we know, and we know it without any, without any hesitation or at any reservation about it. We have full confidence. We know that that the environment absolutely shapes your brain physically, architectonically, etc. Which basically means, and what I mean to say here is that your use of these tools are, in fact, sculpting your brain. They are determining what is possible and, frankly, what is not possible for you to see, feel, think, etc., etc. It really, since everything I've said tonight was a kind of attempt to sort of biologize these things, but one has to basically realize that destiny is this new work on neural plasticity, most of which is only 3 to 8 years old. It basically tells us, really our brain is ours. And there's a wonderful title of a book. I don't really recommend this book, though it's a really good sort of summary of a lot of the science. There's a book written by a French philosopher, Catherine somebody. It's called What Should We Do with Our Brain? And it's a kind of, it's a political issue, and I believe it is. I believe our brains are a political, it's a political site. So what is important to understand is that what you do and what you are literally mutually determining. And, do you want the brain you have? Can you think about another brain, and as I said tonight, another Umwelt, if you like, another realm of possibilities, another field of desire, another set of relationships that appear to you, another kind of forms that populate your world? These people, these kids, for example, in the Mursi tribe in southern Ethiopia, they get up in the morning and that's what they do. They just make themselves up and they sort of enjoy it. They become, if you like, the environment. That was not the short answer I proposed, but for me, what I think is sort of important in a certain sense, you think, why would a guy who's an architectural theorist, why would he be interested in this? Bottom line is essentially it's about the big issues that determine what our environment does to us, and what we do to our environment also ultimately impacts and makes us what we are. We need to be aware of that stuff, and the whole issue around the computer is a critical one. It is very critical. So, thank you.